Scientists, using NASA's solar watching missions, have captured the most comprehensive observations of an electromagnetic phenomenon called current sheet, providing evidence that our understanding of solar flares is correct. Solar flares are intense bursts of light from the sun, created when complicated magnetic fields suddenly rearrange themselves, converting magnetic energy into light through a process called magnetic reconnection. These eruptions on the sun eject radiation in all directions. The strongest solar flares can impact Earth's ionosphere and interfere with our communications systems, like radio and global positioning system, GPS, and also disrupt onboard satellite electronics. Solar flares travel at the speed of light, meaning we get no warning that they are coming. So scientists want to pin down the processes that create solar flares and even someday predict them before our communications can be interrupted. The existence of a current sheet is crucial in all our models of solar flares. So these observations make us much more comfortable that our models are good, said James McAteer, from the New Mexico State University in U.S. A current sheet is a very fast, very flat flow of electrically charged material, defined in part by its extreme thinness compared to its length and width. Current sheets form when two oppositely aligned magnetic fields come in close contact, creating very high magnetic pressure. Electric current flowing through this high-pressure area is squeezed, compressing it down to a fast and thin sheet. This configuration of magnetic fields is unstable, meaning that the same conditions that create current sheets are also ripe for magnetic reconnection. Magnetic reconnection happens at the interface of oppositely aligned magnetic fields, said lead author Chunmin Zhu, from the New Mexico State University. The magnetic fields break and reconnect, leading to a transformation of the magnetic energy into heat and light, producing a solar flare, Zhu said. Because current sheets are so closely associated with magnetic reconnection, observing a current sheet in such detail backs up the idea that magnetic reconnection is the force behind solar flares. This multifaceted view of the flare was made possible by instruments aboard 3 solar watching missions: NASA's Solar Dynamics Observatory, NASA's Solar and Terrestrial Relations Observatory, which has a unique viewing angle on the far side of the Sun, and ANODE, a collaboration between the space agencies of Japan, US, UK and Europe led by the Japan Aerospace Exploration Agency. This is not the first time scientists have observed a current sheet during a solar flare, but in this study, several measurements of the current sheet were observed from more than one angle or derived from more than one